Hello and welcome to the Testing Foundation course. This first lesson is about providing an overview on software testing and on the main concepts that it uses. If you're already familiar with all of these, you can skip this video. Let's start with the obvious question. What is software testing? Simply put, software testing is the process of verifying that a software meets certain requirements and behaves as expected. When we talk about testing requirements, we need to differentiate between the functional and non-functional ones. A functional requirement generally refers to an expected behavior. Let's suppose that we have a login functionality on a web page. We can first test if the login functionality exists. Then we can test if it takes the users to the right landing page where they can input their credentials. A non-functional requirement does not focus on a specific behavior. It rather evaluates the operation of a system. For example, before going live with a product, we'll use testing to answer a question like, is my web page able to cope with 100 login requests at a time? To conclude, the goal of software testing is to collect quality-related information. This helps us decrease risks and make better decisions about the shipment of the product versus going back for bug fixing and redesign. But why is software testing necessary? Software systems are now integral parts of our daily lives. They help us cover many of our needs and even solve some of the challenges that we're facing. We're using apps for home banking, ordering food, planning our transportation, and doing shopping. There aren't too many parts of our lives that are still untouched by software in one way or another. The rise of digital technologies and the emerging business models have fundamentally changed the way that we interact with software products. This phenomenon is called digital disruption. Just think about popular examples like Uber, a driving service that does not own any cars, or Airbnb, an accommodation service without any properties. Their business model is their sole asset, the software. This evolution has made its way in every industry. Software has become the #1 technology in any kind of business. To put it straight, every industry nowadays is in the software business. Thus, software failure becomes business failure. This is exactly why software testing is of paramount importance. It reduces the risk of failure by helping detect defects before the product reaches the customer. And, in the end, it helps in building quality products. There is no one universal process for software testing. Each testing team can follow a specific process depending on several factors. The development approach, like waterfall or agile, can be one of those factors. Then there's the type of product, mission-critical or consumer app. Also, operational constraints, like budget allocations, can influence the process. Nonetheless, it's safe to assume that a typical test process goes through the following stages: plan, design, implement, execute, and analyze. It all starts with subject matter experts or product owners setting the testing objectives in the plan phase. The objectives are often derived from functional or non-functional requirements. The testing approach, the testing schedule, and the success criteria are also points typically addressed in this stage. In the test design phase, we transform the objectives into a list of high-level, prioritized test cases. Then, we prepare the test data and identify the test environment. During implementation, we generally create all of the assets needed for execution. We create manual and automated test cases. We group them together into test sets. And very importantly, we build the test environment. In the test execution stage, we run test sets according to our test plan. We can either follow a defined schedule or test continuously with every code change. We can trigger testing manually or automatically. In fact, automation testing should be the norm in many scenarios. Take continuous regression testing, in which we simply execute previous test cases to make sure that the changes made don't cause errors. Automated test cases are the way to avoid having bottlenecks caused by testing itself. The last stage should close the loop. Remember the goal of testing to provide data on the quality of the software and identify risks related to the software release. thorough analysis and different layers of reporting will offer the means to the stakeholders to make informed decisions about the release, go live, or postpone. This is because a failed test doesn't necessarily mean a bug. One aspect to consider here is the role and the persona of the recipients. A test manager might want to see the main results, but a test engineer might need a more detailed report. Now let's talk about the different ways of categorizing testing. We'll start with test levels. These are determined by the granularity and the scope of the testing. The first level is the unit or component testing. In this one, we focus on testing individual code units down to the level of methods and functions. This is done mainly by the software developers themselves as part of the actual implementation. As the focus is on testing a single unit or function, we typically mock objects and environments that are not in test focus by substituting them with artificial objects. In integration testing, we focus on the interactions between the components or systems. We verify if the interfaces between components are designed as specified. Typically, integration testing is a subsequent phase after assuring the quality at component level. In system testing, we focus on the behavior of an entire software system or product. This test level is often referred to as end-to-end testing. An example would be to test an entire transaction spawning over several separate software products and technologies, making sure that the actual use cases are covered. Proper system testing requires a dedicated pre-production environment. This environment should provide the infrastructure containing all of the products involved in the use case that we want to test, with as few variations as possible from the production environment. The acceptance testing level also deals with the entire software system, but this time we do not generally involve developers or dedicated testers. Instead, we include the end users and other key stakeholders. One of the main purposes here is to check if the actual users interact with the software differently than the way we intended. This can help us spot issues that otherwise remain hidden. This way, we verify if the software is accepted by real users, hence the name of this type. Now let's have a look at some of the test types. Unlike test levels, which deal mostly with the testing scope, test types look at the test approach used. Here are the most common test types. We'll start with functional and non-functional testing. We've introduced them a bit earlier. Just to recall, the objective of functional testing is to validate a certain functionality of the product, like a login functionality. Non-functional testing addresses topics like performance and scaling. For example, having 1,000 users log in at the same time. These two types are not exclusive, but equally relevant. This is true especially nowadays, when bad software performance opens up the way to the other players on the market, all ready to expand. Now let's talk about black box and white box testing. The main difference between the two is the visibility and the access of the tester to the actual implementation. White box testing provides a certain amount of access to the source code to the tester. Black box testing solely focuses on providing a certain input and verifying the output. Alright, now we're getting even closer to our main topic. Let's see the difference between manual and automated testing. At a first glance, it's the easiest thing to do. Manual testing is run by a person, while automated testing is run by an unattended robot. At a closer look, we'll discover that there's a complexity layer for each of them. On the one hand, manual testing can be scripted or exploratory. In scripted manual tests, we have predefined steps of operations, followed by specific verification steps. This type of testing is intended to be executed the same way every time that it's performed. Scripted manual tests are repetitive actions. So, just like any other repetitive tasks, they should become automated checks, whenever it's technically possible and feasible in terms of effort. The exploratory testing is still manually performed, but it typically provides only a high-level charter. Then it leaves the rest to the actual tester to explore in detail. This technique requires creativity and can be very beneficial and effective. And on the other hand, Automated testing is also of two types, matching the two main layers within a typical software application, the UI and the API. So naturally, automation testing can be differentiated between UI testing and API testing. The UI layer is the interface that users interact with. It can be a web form, for example. By testing the user interface, we can make sure that our software behaves as expected for users. Automating the UI testing may seem easier, as interacting with the UI is something very natural for us humans and is extremely relevant for the real users. Yet, there are two downsides of UI testing automation. The first one is triggered by the absence of a reliable UI interaction technology. You'll see that this is not the case with UiPath. The second one has to do with the synchronization. In most cases, the UI will be ready at the end of development, and there may be little time left for thorough testing. Let's go to API testing. This type focuses on testing the business logic by automating APIs directly. It could include several interfaces and protocols, such as SOAP, REST, queues, and many others. The main advantage of API testing automation lies in its speed of execution and reliability. That's because APIs tend to be stable over time compared to UIs. By focusing on testing the API layer of our software, we evaluate most of the business logic. And we only have additional UI-specific cases to address. Alright, we're done with presenting the main concepts related to testing. In the next video, we'll meet the UiPath test suite, and we'll find out how it covers the main types of testing highlighted here. Thanks for watching.